So saying arc in front of a trig, in front of a trig function is the same thing as saying inverse, right? All right, so let's look at just that example that I have right at the very top. It says if we're given an equation like the cosine of theta is equal to the square root of 2/2, then think about what we're going to do in order to solve for theta. We're trying to solve for that angle measure. So we've got to take the inverse cosine of both sides. So basically we are having to undo the fact that this cosine is here, and so that we're taking the inverse cosine. Now, we're used to having this operation be something that we're familiar with, and so that's what's a little bit confusing about this, just because we don't really know or understand how this operation works, right? So we can write that as cosine to the -1, and I think that's the most helpful just because that's how you're going to see it on your calculator. But please be familiar with the arc cosine, the arc sine, the arc tan also, okay? All right, so I want to do a little bit of review, and I want you to notice these are all problems that are where we're using our calculator. We're going to get to the unit circle stuff here in just a second. But for all of these, we are using the calculator. The process is essentially the same, but I want you to notice I'm using a little bit different format for how I am writing out these questions each time, just so that you can see some of the different ways that it might be written. It means the same thing, right? We're going to do the inverse sine of 0.88. We're going to do the inverse cosine of that 0.23, and so on. So try those for yourself. Plug those into your calculators. You should be in degrees. And then go ahead and do these. Do this one here, and this one here, and this one also. And I'll talk to you briefly about why I have those kind of separate in a second. We ready to go over our answers? Okay, inverse sine of 0.88. Alex, what'd you get? 61.64 degrees. I like that you went out to hundreds. Let's go 2 places after the decimal. I like that. Okay, for this second one here, this cosine of A or alpha, it's hard to tell. I think that's supposed to actually be an alpha because it looks a little weird, but it doesn't matter. If you're given something like that, though, you want to, I'm mentioning that just because you're going to want to say whatever that letter is, at A alpha is equal to whatever the degree measure is. Ashton, what'd you get for that? 76.7. Okay, 76.7 degrees. Sounds good. Arc tan of 3, Ricky? 71.5. Actually, 5.7 probably, if we go to the hundreds, it looks like, because it was 0.565. Yeah? Okay, so let's round up. Okay, and then that last one, y is equal to, Valeria, what'd you get for that one? 145.08. 0, let's round up, right? So it's 0.09 degrees. Sounds good? Okay, so here's the deal, guys. I kind of give you this section. You guys have a calculator that has the inverse secant and the inverse cosecant and the inverse cotangent buttons on it. But not all graphing calculators do. The TI Inspire does, but if you're on another TI, a TI-84 or something, it doesn't. So I put this information on here just to kind of help you recognize and realize if you were on a different calculator, here's the process that you would have to go through. But luckily, we've got those nice keys there. So Andrea, what do we get for the inverse secant of 6? 80.41. Okay, 80.41 degrees. And then the inverse cosecant of 4, Charisma? 14.48, sounds good. Degrees. Arc cotangent of 2.4, Izzy, what'd you get? 22.62. 22.62 degrees. And then that arc cotangent, what'd we get for that one, guys? 90. So inverse cotangent of 0, I want you to think about, all right, let me see, do you have that on your calculator? I want to see what it actually told you.
I didn't do that one yet.
Okay, go ahead and do that one, because I want to see what you got on there. Okay. Yeah, so that's where it can be a little bit weird on if you're thinking about this in terms of the arctan, if you're thinking about this in terms of the inverse tan. If we were to do reciprocals, we would get it that it's undefined, but in this case we do actually get that it is 90 degrees. I just wanted to see what it would say on your calculators there for you. So it is giving you the 90 degrees then? Yeah. Okay. All right. Okay. So I'm going to kind of talk to you about what this is sharing with us down here. I'm going to draw in a little bit of a visual to help you with this. We're going to talk about a few different things. When we are looking at inverse functions of values that are on our unit circle, so we're done with the calculator for now. You can set those aside. Pull out that handy dandy unit circle because we're going to be using just that. When we are looking for inverse trig functions, if we are, in some instances, we want to consider the entire unit circle, and there could be multiple answers. But in other instances, we limit the quadrants in which we look for our answers. And so this chart down here at the bottom of the page is to kind of help us and tell us where we are going to look for those specific answers. So in general, I want you to think about what this is telling us, okay? It should be pretty clear if you notice, if we are looking for any inverse trig function that is positive, we're going to look in quadrant 1, okay? There's always the exceptions to the rule. Quadrant 1, though, for positive. So for the negatives, that's where the exceptions come in. In general, the rule or the guideline is that when we are looking for an inverse trig function of a negative value, we want to look in quadrant 4. If you look at the values that you see there, most of them are quadrant 4. Here's the issue. If we try to find an inverse cosine of something negative in quadrant 4, we're never going to find it because cosine values are not negative in quadrant 4. So for inverse cosine values of something negative, if you notice, it's saying instead of looking in quadrant 4, we're going to look in quadrant 2. And that also applies to its reciprocal. And then there's always that extra exception to the rule. Guys, you very rarely will see an inverse cotangent, let alone an inverse cotangent of something negative. Okay? So in general, I'm trying to spell here and I'm not doing a very good job. If we are looking for an inverse of something positive, we're always going to look in quadrant 1. If we're looking for a negative value, the general rule is that we look in quadrant 4, except for our cosine and its reciprocal. And then we have to look in quadrant 2. Because cosine values and secant values are not negative in quadrant 4. Okay? So some people prefer to kind of think about this or get this memorized based on this table. And some people prefer to kind of think about this or consider this information kind of in a visual format. So I'm going to do that for you all as well. Okay? So if we are looking for an arc sine, I'm going to kind of make a little make some little tables here, make some visual graphs, I should say. So if we are going to look for inverse or arc sine values, we're going to look for positive values in quadrant 1. We're going to look for negative values in quadrant 4. That's what that means. Now, that's also the case then for our arc cosecant, which is our reciprocal. Okay? For arc cosine values, in other words, inverse cosine values, for positive values, we're going to look in quadrant 1. For negative values, we're going to look in quadrant 2. And this as well is also going to be the case for arc secant, or in other words, inverse secant. Okay, and then for arc tangent, we're going to look in quadrant 1 and in quadrant 4 again. So you can kind of see the visual here of, you're looking at two quadrants right next to each other. We kind of need to make a little bit of a note down here. And like I said, it's very rare that you're going to see an arc cotangent. But in case you do, that's kind of the weird exception to the rule again. It's the exception to the exception of the rule. So it may help to kind of have those visuals. So now I'm going to help you actually see how we use this and what this really means, okay? So flip over to that next page. Let's take a look. When we are looking for an arc sine or an arc cosine or an arc tangent, think about what we're looking for. We are finding an angle measure. So when we are doing this on our unit circle, we're essentially working backwards from what you guys have done already, right? Okay, so think about that. We're going to kind of be working backwards. Think about what this is asking us to do. We are finding an inverse sine, and it's a positive value. So we know we want to look in quadrant 1. Some of you may want to even make a little note. We know we need to look in quadrant 1. And I want you to look in quadrant 1 and find where is the sine value, in other words, the y, equal to 1/2 at 30 degrees. There you go. You have just solved your first inverse problem using your unit circle. Now, in some instances, I might ask for degrees. In some instances, I might ask for radians. So let's go ahead and practice using both. So let's go ahead and put our 30 degrees, but also our pi over 6. Go quickly, yeah. Okay, think about that. Our answer was a degree measure, an angle measure, right? Okay, arc cosine of 1. That's something positive. So we're probably going to need to look in quadrant 1 for that. I'm saying probably just because this is a little bit of a different situation. Okay, Ricky, you're getting distracted there. Can you get that closed up? Because I need you focusing on this, please. So arc cosine of 1. So we're looking in quadrant 1 for where the cosine value, in other words, the x, is equal to 1. Where is that? Yeah, there you go. We're at 0 degrees or 0 pi. Yes, although typically the directions are going to say something like, consider the interval. It's a great question. Usually the interval is written as either 0 degrees to 360 degrees, and then it's a parentheses there, so it's saying use the 0 degrees rather than the 360. If it were in radians, it would be 0 pi to 2 pi, but it would be written like that. So good question. I'm glad you brought that up. Okay, this one's got a negative attached to it though, so let's think about where we're going to find this. So this is saying find the arc sine or the inverse sine of a negative value. So first thing is we have to decide which quadrant we're going to look in. What quadrant? Good. We're in quadrant 4. And we're looking for where the sine value, in other words, the y, is negative square root of 3 over 2. Where is that? 300 degrees or 5 pi over 3. So practice giving me both for now, please. Tangents can be tricky because remember we have to do y over x, right? This is something positive though, so which quadrant are we in? 1, good. In quadrant 1, and we're looking for where the tangent value is the square root of 3.
60 pi over 3.
There you go, 60 degrees pi over 3. Okay, a couple more examples of that type, and then we're going to do something a little bit more complex. Okay, this is an inverse cosine of something negative. So what quadrant do we look in? 2, good. And we're looking for where the cosine value, in other words, the x, is negative square root of 3 over 2. What is it? Yes, someone whispered it. 150 degrees or 5 pi over 6. There you go. And then last example from this section, arctangent of something negative. So what quadrant are we in? 4. Good. We got to look in quadrant 4, and we're looking for where the tangent value is negative 1. Yeah, 315 degrees. In other words, 7 pi over 4. Okay. What do you think? Questions, comments on that? Okay. All right, so we are going to look at what's referred to as composition of these functions now. I want you to notice that the order is a little bit different. So the process that we're going to use on some of these, we're kind of going to start, we always start from kind of from the middle or from the inside out. Or in this case, the way these are written, what it looks like is that we're going to consider this part first, and then we will deal with this after. Okay? I'm giving you a little bit of a heads up. We do have to consider the quadrants, so we'll talk about that here as we progress through these. Okay, so the first step in this is that we need to find the arc cosine of a half. So what quadrant are we in? Okay, we're going to look in quadrant 1, and we're looking for where the cosine value is a half. And what is that? Where is that? 60 degrees. So this part right there, that arc cosine of a half, that's equal to 60 degrees. And so now basically this is saying take the tangent of 60 and give me an answer. So it's kind of a two-step process there. So we found 60 because that's our arc cosine of a half, our inverse cosine of a half. And now we're supposed to take tangent of 60. What does that give us for our final answer then? Square root of 3. Beautiful. All right. Okay, let's look at this second example here. On this one, if you notice, we're not doing the inverse trig function first. We're going to do that second. So this is saying we got to deal with this cosine of 2 pi over 3. So go to where 2 pi over 3 is. We got to find the cosine value. What is that equal to? Yep. So we get negative 1/2 for that part. And now the second part of this is now we're taking the inverse sine of that negative 1/2.
Wait, how should you get negative 4 pi?
Look at this first part of what we're doing here, Carter, is we're taking the cosine of 2 pi over 3.
So just plug that in the calculator?
No, unit circle. Go to 2 pi over 3, find that value, and give me the cosine, which is the x coordinate. And it's negative 1/2, right?
Yeah.
Okay. And then we're doing the inverse sine of negative 1/2. Now, if we're doing the inverse sine of something negative, what quadrant do we need to move into? Yep. So this, what quadrant was this 2 pi over 3 in? Okay, so we started in quadrant 2, but now that we're doing this inverse sine, we're having to jump down into quadrant 4 to find our actual answer here. So inverse sine of negative a half, what do we get? Yep, we get 330 degrees or 11 pi over 6. Actually, our original question had radians, so our answer should be in radians too, shouldn't it? Does that make sense? I hope. Okay. So notice the order in which we are doing this, our answers are going to be a little bit different, right? For here, we got an actual value from our coordinates, but here we got a radian measure, an angle measure. So the order is going to affect that. Yes.
So, if you're in a calculator, could you not just type this?
No, but you're not going to have your calculator. You're only going to have your unit circle for this. Okay? All right, next one. Inverse cosine of negative a half, right? This is equivalent to negative a half. So what quadrant are we looking for this answer? Oh,
Two.
good. We're in quadrant 2. And the inverse cosine of negative a half, what does that give us? Yep, we get 120. And now this is saying, take the cosine of 120 degrees. What do we get for our answer? Negative a half. So on that one, we ended up right back where we started, right? That does not always happen, so be careful. Nicole.
Does it have to be negative half like I put, because my calculator gave me 0.5.
You're using unit circle though, not calculator. So yeah, you're not gonna see negative 0.5 on your unit circle. You're gonna see negative a half, okay? Because remember, we are strictly using unit circle.
The cosine's not involved.
Yeah, do you see that? Like this is saying we're taking the cosine of the inverse cosine. So they're like undoing each other, okay, right? So that's how on this one we ended up right back where we were. But be careful with that because we do have to consider quadrants, and so sometimes it does change. Like this next example, you're going to see we have to switch quadrants. Okay, so for first part of this is saying cosine of 5 pi over 4. So we need a value, we need a coordinate or a value there. What do we get? Yeah, we get negative square root of 2 over 2. And now we are doing the inverse cosine of that. So what quadrant do we need to move to? Yep, we need to move to quadrant 2. And so that tells us that we are at what place? 3 pi over 4. Excellent. So notice on this one we did have to switch quadrants. Right? On this one over here, we didn't, but on this one, we did. So you do have to kind of check it. You can't just assume it's going to give you that same answer again. Okay? All right. A couple more examples, and then I'll explain about homework. So these are a little bit more involved. I put a little note here. This is kind of a next section. Carter?
What's the point of arc sin or arc sine and arc cos if it's just the -1?
Right. It just means the same thing. It's just another way of saying that inverse sine or that inverse cosine or whatever. So, yep. My guess is that some mathematician along the way, whoever first was dealing with this, wrote it one way, and then someone along the way decided they wanted to kind of put their own mark on it and, say something a little bit different or do something a little bit different to get some credit. I don't know. It's just a guess. Anyway, okay. So let's look at these. we've got to focus our attention first on this arc sine of negative 2 over 5. So that means we are looking, it's an inverse sine of something negative. Which quadrant should we look in?
4.
Okay, quadrant 4. Is there an arc sine, is there a sine value in quadrant 4 of negative 2 over 5?
No.
No. So when you go to that unit circle and you find that the value's not there, then you know you have to do this extra thing, that this is one of these that's more involved. So what we're going to do is draw a triangle. Yes. You guys know how to draw triangles. You know how to do this. So the first thing to recognize or realize is to think about the fact that this arc sine of negative 2 over 5 implies that we're saying that the sine of some angle measure is negative 2 over 5, right? So we can use that information then in order to help us draw our triangle. So we know sine is opposite over hypotenuse. And so now we can finish labeling our triangle, right? We're going to have to do some math here and figure out we're missing a side here. So we've got to do 25 minus 4 is equal to x squared. So x is the square root of 21. So this length is the square root of 21. So now that we have our triangle, what this is ultimately asking us to do is figure out what the cotangent of that angle is. So we don't even figure out what the angle measure is, but we know what the ratio is for it. And that's what this is asking us to find. So the cotangent, we know tangent is opposite over adjacent. So the cotangent we know is going to be adjacent over opposite. So we get the square root of 21 over negative 2. So we kind of were able to skip a step in there because we didn't have to find the angle measure. We just used our triangle. Okay. All right, questions on that one before we look at this other? Andrea, were you stretching or did you have a question? Okay, that's fine. Okay, let's look at this second one. If you try to look on your unit circle for an inverse tangent of something negative, what quadrant would we be in? 4, again, yep. If you try to find the inverse tan of negative 2, it's not going to be there on the triangle. So that's your hint. Ding, 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 ding. Your brain should be saying, oops, I got to draw a triangle because it's not on my unit circle. Okay? All right. So this tells us that we have that the tangent ratio for that angle measure is negative 2 over 1. And we know tangent is opposite over adjacent. And so then we can use Pythagorean theorem to find that other side. We're looking for the hypotenuse on this one. So this is going to be 4 plus 1 is equal to r squared or h squared. So we get the square root of 5 for r. And now what it's really asking us to do is figure out what the cosine of that of theta is. So we don't know what the angle measure is, but we do know that the cosine is going to be 1 over the square root of 5, which gives us root 5 over 5 when we rationalize that. Okay. All right, we're almost there. Hang in there. Next page. I do want to show you a couple of examples where you are considering the full unit circle. So you're going to see a little bit of a hint. You're going to see it written more as an equation rather than just a specific. Like if you look at page 19, all of those are just a specific inverse. That means you have to consider and limit or restrict where you are looking for your answers. However, on these types of problems where you're solving this equation, it says solve equation using inverse trig functions. The directions will typically say, Andrea kind of asked about this earlier, it'll tell you to consider the interval from 0 to 360 or from 0 pi to 2 pi. And so that's telling you, first of all, consider the entire unit circle. And then it's also telling you whether your answer should be written in degrees or radians. So we're going to practice both for now, just because I'm not giving you any specific directions. Okay, so I need you to realize we're looking for where the sine value on your unit circle is equal to -1/2. Guys, there are two places that you need to give me. Two different angle measures. Where are they? There you go, 330 and 210. So 11 pi over 6 and 7 pi over 6. So notice, once you find one of those answers, jump to the other quadrants and find the corresponding reference angle, and that's going to help you decide where it should be. If it's sine values and they're negative, you should know you're looking in quadrants 3 and 4 though, right?
Put both down?
So you put both, yes. Yes.
And then that's it. Just do it.
Then you're done. What about the next one? Tangent of x is equal to 1.
45.
Good. 45 degrees, which is pi over 4. And where else? 225. If tangent's positive, you know it's 1 or 3. Right? Quadrants 1 or 3. Okay, this last one, cosine's negative, so you know you're looking in 2 and 4, quadrants 2 and 4. You're looking for where the x value is negative root 2 over 2. Good, 135 and 225. So 3 pi over 4 and 5 pi over 4. Okay. All right, so 2 parts to your homework. The first part is page 19, and you need to use either your paper plate or you cannot take those unit circles. So if you would rather use the unit circle that you're using as reference now, then grab your phone and take a picture of that. Otherwise, use your paper plate. I will get you the worksheet. It does, so page 19 gives you practice with strictly like limiting the domain, limiting which quadrants you will look in for your answers. It also gives you some practice with some of the triangles.
So all we have to do for page 19 is figure out what quadrant is.
No, you got to give me the values also. So give me degrees and radians. Okay? And then the worksheet will be, the worksheet is more like these types of problems where you're finding over the full unit circle. Okay?